All right, so especially if you just got this Z-score chart, you're gonna want to know how the hell to read this thing. All right, so let's do a couple of warm-up problems. All of these problems are normally distributed. Why is that important? I like it. Because you can't use the chart unless it's normal. I love it. Everybody, guys, shut up. Where does it show you on the chart? It tells you when you can use it because it's got a freaking normal curve there. So it's just a little reminder. Two things right there this is a reminder of. You can only use it for normal curves. And when you look up a Z-score, it tells you the area below it. Yeah. Okay. How did I know? So, let's say I have a normal curve. Yay, I can use this thing. And then I want to know the probability that Z is less than 0.58. I desperately want to know that. Can you draw that for me? I want somebody to do like the word that and make it 3D and say, there, I drew that for you. Don't do that. Draw the picture for this. All right, let me catch up to you. What goes in the middle of this picture? We know it looks like this. Bam! Or maybe even better than that. That's something like this. What goes in the middle? 0. So where's 0.58? It's somewhere up here. If you put yours there, you put yours there, who gives a shit? It just has to be in the right relative place so that your picture helps you figure out if the answer makes sense. Where do I shade? What area am I talking about? To the left, right? So, it's still relevant. Most of my references are irrelevant. That's semi-relevant. So you got to shade, and of course the inequality symbol is an arrow. Right? Screw the alligator. Don't screw the alligator. That's weird, but it's an arrow, so you shade that way. Don't try it, kids. It's not personal experience, but I think you should. Now, how do I use this chart? How do I look up 0.58? Well, first off, is that number positive or negative? That's crazy, so I probably want to use a side that says positive. Now, if this is the first time you're looking at this chart, here's how it works. 0.5, and then the columns are the second decimal place, so 0.58. So that would be the area below it. Can somebody tell me why that answer makes sense? Relatively, why is that answer that? Not why is it exactly 0.7190, but what about that makes sense? Looking at the picture, what about that makes sense? I knew the probability should be bigger than. What's the mean do? Cuts it in half. I love it. I keep talking and fill in the blank sentences, I know. But the mean cuts it in half because a normal curve is symmetric to the mean. So mean cuts it in half. So if I'm talking about the mean, what percentage is below it? 50%. So if I'm talking about something below a number that's up here, it's got to be more than 50%. Does that make sense? Okay, so that answer makes sense. If you got 0.3 something, you should immediately go, well, that don't make no damn sense. Let me go try that again. Maybe you looked at the negative side. Oops. You guys see what I'm saying? So the picture should be useful. If you put things in the wrong place, it's going to mess you up. It's supposed to help you. Yes?
Did you tell us the last class if you look at the negative side, it'll tell you?
So again, if I would have said greater than, this area is the same as the area below negative 0.5. That's when the shortcut kicks in. But that's not a really like crazy good shortcut. It takes a second off your time. Ooh, right? All right. So what percentage of Z-scores? So for example, if there was a test and it was normally distributed to the grades, and your grade was a 0.58 z-score, what percentile are you in? Oh, I love this question.
50.
No. What's percentile mean?
72.
Yes, it's roughly 72nd percentile. What's a percentile mean? The percentage that is below that, right? So if I have a 0.58 z-score for my test grade, does that mean you made it 58%? No. That means you're a little more than half a step above average. You guys semi with me? What grade could that represent? I don't know. If the average is 80, it could be like 85 or something. Depends on the size. If the average is 30, it could be 37. Something like that, right? Just a little above average. So 37 could be good, relatively, if the average was really freaking low. Yes?
Could you just like explain quickly like why it's the area, not the z-score? And why you know, like you said the percentile is based on the area, not the z-score?
So percentiles are percentages, a percentage below something. A z-score is a place.
Oh, okay.
I'm at 0.58 steps above the mean. It can't represent an area of percentage below something. When I look it up in the chart, then I get the percentage below. So does everybody see this? If you have a normal curve, so if heights are normally distributed, so if your height is 0.58 z-score, then you are taller than almost 72% of other people. Do you guys get that connection? Do you see how a lot of things we talked about have led up to this? Little pieces just flying at us. Okay. Let's try another one. What's probably z is greater than 2.18? Let's go ahead and graph that and try to figure it out. So let me catch up to you. What goes in the middle? Why? What the hell, man? You said put a zero. Why am I putting a 0 in the middle? Because it represents the what? The mean, yes. And I have z-scores. So what's the z-score for the mean always? Considering the fact that a z-score is the number of standard deviations away from the mean. So the mean is how far away from the mean? 0. So in terms of z-scores, the mean is always 0. I like it. So why do I put a 0 there? Because the question is talking about z. That's why. Where's 2.18? And where do I shade? Right. Everything's to the right. Love it. So when I look up 2.18, will it answer my question? No. It'll be the opposite of what the question was. And we know exactly how to answer, how to handle that. What do I do then to get the actual answer? 1 minus what I get. See, we've done that before. We answer the opposite of the question, so we do 1 minus. Holy shit, Jeff, that sounds so familiar to what we were doing before. It's exactly the same thing. What do you get when you look up 2.18 in the z-score chart?
0.985.
What is it, sorry?
0.985.
985? 4. 9854? All right, and real quick, I want to point out some things. I'm doing things very purposefully. Down here are z-scores. Up here are areas. Do that for yourself, because sometimes an area will look like a z-score and vice versa, right? So you got to be sure you put things in the right place. So right now, looking at the picture, I know I'm not done, because the shading is the question. So what's the answer then? This is where, if you look up negative 2.18, if you want to try it out, if you look at negative 2.18, you will get the answer. That is a shortcut. Why does it work? Because the area that's in here is the same as the area that's below negative 2.18. Because it's symmetric. Boogie, woogie, woogie. Right? All right. One more type of problem, and then I'm going to unleash you on this handout. So let's say, again, I got a normal curve. So don't look that way when you write it. Normal curve. The mean is known to be 112, and the standard deviation is known to be 17. And I want to know the probability that, let's see, Jeff, x is greater than 91. Way to go, buddy. What's different about this problem?
You gave us a standard deviation. And it's also this mean contribution 0.
Do I start with z-scores? Nope, that's the main difference. That's why I had to give you that. Because one thing you want to do is make this into a, so then it's just the problem is just like that. So this is if you already have z-scores, you can look right at the chart. If I don't have z-scores, that's not an x-score chart. You got to make it into a z-score. Try to draw it. What's going to go in the middle now? 112, because they don't have z-scores. I have x-scores. So try to draw it, try to shade it. Get as far as you can with this question. Like some of you guys are like looking at it because as far as I can go. All right. Shit wherever they want to. The picture's supposed to help you. Where do I shade? Yeah, because I want greater than. Why did I put that there? What does that mean? That's that mean turned into a z-score. So what do I put underneath here? Yeah, I got to take a minute and calculate what that is. What's the z-score formula? I like it. So if you haven't done it yet, try to convert 91 data point into a z-score. Data point I'm curious about is 91. The middle is 112. Standard deviation is 17. So it comes out to be negative 1.24.
Yeah.
And again, if I look that up, it's not going to be the right answer. I've got to do 1 minus. So if you look up negative 1.24, 1.2. Now watch this. This kind of sucks. Don't do this. 1, 2, 3, 4, because that's not 4. Ah, shit. The first one's 0. So, you know, just a little thing to be careful about. 1.24. There. 0.1075. Where does that go on the picture? No, to the left is below. The chart will always tell you the area below what you looked up. So where's the area below what I looked up? Right there. No, by now I've forgotten what the hell it was. 1075?
Yes.
Okay. So what's this side? 8, 9, 2, 5. Alright. That's enough of me talking. Let me give you this too. So on this handout, the first problem is all z-scores. And the second problem is like the one we just did. I give you the mean and standard deviation. I like it.